So in this course, when we ask you to do the programming part, you will be writing the code in Python. However, you will notice that when I am describing algorithms, or when there are questions about algorithms, the mathematical algorithms, on the homework, you will see that I will be using or requiring the use of a certain language that we call pseudocode. Okay? So we have this notion of pseudocode. Okay? So what is pseudocode, and why do we want to use it, and why not just stick to Python? So pseudocode is a language that is very powerful for describing algorithms. It is somewhere between a formal programming language that has exact syntax that you have to use and English or any other natural language, in the sense that it is not as formal as a programming language. It gives you wiggle room for using structures or using English in them. But it's not like English that it is ambiguous or not structured. Okay? So pseudocode is very important. You are going to be seeing it throughout the course. We are going to be using it, and it's very important that you feel comfortable with reading pseudocode. Okay? There are going to be on the website some notes about syntax that we use for pseudocode. Of course, the syntax is going to be not very formal, because you might ask me, why don't we formalize pseudocode? But if we formalize pseudocode, what did we get ourselves into? We have defined yet another programming language, right? So we cannot formalize the syntax of pseudocode perfectly, because otherwise we have again created another programming language. So pseudocode, when we use a certain notation, doesn't mean that this is universal notation. If you look at different algorithms textbooks, you might see differences in the pseudocode that the authors use. Usually it reflects the programming language that the author has been using, right? So for example, the sign for assignment, how do I assign the value 5 to x? You might see some books saying x equal 5. Okay? You might see some books saying x colon equal 5. You might see some textbooks saying x left arrow 5. Okay? In all of them, this is assignment, right? Of course, if you're using Python, you have to use one specific symbol for assignment. If you're using C++, you have to use one specific symbol for assignment. In pseudocode, it's not that this is right and these are wrong, or this is right and these are wrong. No, you will see all these ones in different textbooks. Okay? Now, every textbook tries to be consistent. So if a textbook is using this for assignment, you will see that the textbook is using this throughout the book. Okay? But it's very important to keep in mind that we are not going to be compiling the code. We are not going to be really running the pseudocode. So it doesn't matter if it was this or this or this, as long as we are consistent. For example, in this course, we are going to be using this notation. X left arrow 5, it means I'm assigning the value 5 to x. Okay? So you might be asking, again, why am I using pseudocode again and not Python? Okay? Python, in some sense, is a high-level language, right? One of the major issues or the rationale behind using pseudocode is that pseudocode tells us what we want to do. Tells us what we want to do in terms of the algorithm, not necessarily how we want to do it. Okay? And when I am describing the algorithm to you, it's very important that I tell you what I want you to do. These are the steps that I want you to follow to achieve the task. Now, how you want to do each one of these steps, again, it's very important sometimes to leave room for the user or the programmer to implement them the way they feel comfortable or the way they find them to be more efficient. Okay? Let me illustrate. Suppose I'm writing an algorithm or a piece of program, and somewhere there I have a list L, and I want to find the minimum element in that list. Okay? The smallest element or a smallest element in that list. So here's one way I would write it in pseudocode. I say x is the smallest element of L. Okay? So this is one way that I can describe this in pseudocode. Notice I'm using English, I'm using some mathematical symbols, but it is basically telling me that I'm assigning to x the smallest element of L. Now, I have told you what I want to assign to x, the smallest element in L. Okay? Or a smallest in case there are multiple ones. Now, contrast this to the following. We can do this. So this is a part of code that says initialize x to infinity, very large number, then loop throughout all the elements of L. Here I'm assuming that the list is indexed from 0 to n minus 1 if it has n elements. And for every element, if Li is smaller than x, if the first one is smaller than x, I'm going to replace x by that one. And I repeat, if the second element is smaller than x, I'm going to put an x the second element, and so on. What does this code do? This code is identical to this. This is going to actually find the smallest element in L and set it and put it in x. Now, is this telling us anything more than this about what we want to do? The answer is no. I would argue that this is not telling me anything more than this about what I want to do. It's basically telling me I want to set to x the smallest element in the list. What is this giving me more than this? It's telling me the how. How am I doing it, right? So this one is saying, to find the minimum element in L, I'm going to be scanning the list all the way from the left to the right to find the smallest element, and I will return that, okay? So this is where pseudocode gives me wiggle room to play with how much description or how much detail I need to give in the algorithm description. This is acceptable pseudocode. This is acceptable pseudocode. This is not acceptable in Python or in C++ or in Pascal. This, if it is translated to proper Python, this would be acceptable. This is very detailed. And this, in terms of, instead of putting left arrow, I would put equal. In terms of this mathematical symbol of infinity, I will have to put proper thing in Python. But this is basically would translate one-to-one, line for line into Python, right? But again, in terms of what am I trying to achieve, this is not telling me anything more than this. In fact, I would argue that this is more readable than this. But again, if I say, how long does it take to find the minimum element in a list, it's not easy to answer that question with this. Because, okay, you're telling me that I find the smallest element. It is easy to answer this. If the list has n elements, this is going to take on the order of n operations. Why it's not easy to say what is the running time of this? You might say, well, look, this is how I would find the minimum element. That's not necessarily always the case. I will give you another way of finding the minimum element, which is sort the list L in increasing order, return L0, okay? This is another pseudocode that is doing exactly the same like this in terms of what we want to achieve. It is sorting the list L in increasing order, returning the first element in L after it is sorted. Now notice, this is different than this, different than this. All three of them are finding the minimum element in the list. This is going to differ from this in terms of the details, and also it's going to differ in terms of the running time. This one here, for example, what is the time it takes to sort the list? Returning this is probably one operation. If I can go to that first element in the list in one operation, then this is not going to take many operations, or going to take a small number of operations. But how long does it take sort? So now you start seeing that pseudocode gives me this flexibility of, in very simple, readable way, describing what I want to do, like this. But also it allows me the flexibility to specify exactly how I want to do it. Here, I'm saying do it like this. Sort the list, return the first element. This is going to be correct. It's going to return the smallest element. This one, I'm saying scan the list in order from left to right and find the smallest element. This one doesn't tell me anything about how, okay? Of course, when you write something in a real programming language, Python, C++, or Java, for example, you cannot do this. You cannot get away with this. You have to know exactly how it is implemented and how all the details. You have to figure out the details. Are you going to be doing this? Are you going to be writing a sorting function, sorting and then returning the first element? So this is why we use pseudocode. Describing an algorithm like this, look at this here. In one line, I said sort the list. There's nothing ambiguous about it. Sort the list in increasing order, right? There's nothing ambiguous. If I wanted to write this in Python, I have to write a long piece of code that in fact does actually the sorting, okay? Whereas in pseudocode, it was this magic line says sort in increasing order. I don't need to describe anything more because it's very well defined. Okay? So it allows me, again, to abstract things out while still maintaining readability and understanding of what I want. I want the smallest element. At the same time, if I decide to go into more details so that one understands exactly how I want it to be done, I can use the pseudocode as well to achieve that. Okay? So this is why we use pseudocode. It's a very high-level language, abstract, has flexibility. It allows me to write things in English. It allows me to use mathematical symbols and so on. But at the same time, it's sufficient to describe what I want to do. Okay?